Let's see if my restart worked. Because I'm a real tech support guy, right? Yo. Of course, yes. You can always use your phone calculator, Abby, except on tests. Okay, what's first row? Oh, wait. Does anybody need more time? No problem, no rush. We got all 80 minutes. I'll allow it. Okay. All right, I'm going to put the table up. It doesn't matter if you're not done. It's fine. The pink arrows, which probably look red to you guys, are ones that have tricky things in them that I expect somebody might have screwed up. Check your work over. Take a moment. Make sure you've done it all right. And then I'll talk about the 6 arrows. It'll only take a second because I have the utmost belief that you all did just wonderfully. First one's easy peasy. Second one, first weird arrow. Why is that 3 even though there's a negative there? Mantaj. Right. The base can't be negative unless there's brackets. So what does that mean? Well, that means the 3 repeats 3 times, but there's a negative in front, so it ends up negative at the end. Yes, that was something else that I would have brought up. You can also remember that this is technically -1 times 3 cubed. And the 3, since it's an exponent and it only applies to what's immediately right, it only applies to the 3. Avnor. No. Because if you do -3 times -3 times -3, then the negative is repeated. You will get the same answer, but that is not what this is because there's no brackets. Understand? If this was written like that, then it would be this. Cool? All right, next trick is what I just talked about with Avnor on this row. Why does the negative continue here?
Because base with the negative is in brackets.
The negative is part of the base, so I must repeat the negative, which is why I end up with a positive number here. What if this was a 3? Then what would I have to add in this row? Another -5, and my answer would be negative 125. Everybody cool? That's the first trick that exponents can throw at you, where the bases actually are. Everybody should be good with the next two, no problems. They're the easy ones you're comfortable with. The next one has an arrow. Why? Because that negative repeats. So what do I have to remember when I write it out? I gotta remember the bracket. This is negative. Why? Negative times a negative is positive, but I went an odd number of times. What if this was to the 8th? Then what would this answer be? Positive 1. Everybody cool? That's the next trick that exponents throw at you. Everyone should be good with 10. Why did I have numbers all the way down until there? Why does that have to still have an X? Harry? Because there's no base. We don't know what the base is, so we have no idea. If I told you X equaled 2, could you put a value there? What would it be? 8. Everybody cool? Sweet. The next one is tricky. I have a negative answer, but a positive base. Since the base is positive, I have to repeat 2 5 times. That gets me 32. But I need a negative. So that's why the negative's out in front. This is what Riley was talking about. This is essentially -1 times 32, because 2 to the 5th is 32. Everybody cool there? Excellent. And then these two different ways I can get 9, right? There's actually a third way, which is the same as at the bottom here, right? I could have had 9 to the 1. And then this tricky one here. Even number of negatives, so the answer should be positive, right? But I got a negative out in front, so the whole thing's negative. Everyone good? Now what if I made this 7? Then I'd have another -4, which would make this like 16,000 and something, right? Would it be positive or negative if that's a 7? Would that be positive or negative? Positive, because the extra exponent would get me negative inside the brackets, and then a negative out front times the negative in there would get me a positive. Is everybody now perfectly comfortable with all exponents and all bases as long as they're numbers? Spectacular. Turn the page over. All of you have done this too. But, again, depending on your grade 9 teacher, I don't know how far he or she took you. So I am assuming they brought you nowhere and starting from scratch. Everybody okay with that? Won't take long. We'll rock through it. Multiplying powers of the same base. 3 squared times 3 cubed. Now listen to my words right now. I know you all on the tip of your tongue have this answer. But listen to what I am going to ask. What do you do to get that answer? Who haven't I picked upon? Jewel. You add the exponents. That is what you do. So it would be 3 to the 2 plus 3, which would get me 3 to the 5th. Now tell me why it is 3 to the 5th. And you're not allowed to say, because you add the exponents. Caden?
Well, it was 3 squared, 3 times 3, and then 3 cubed is 3 times 3 times 3, so it's just 3 times 3 times 3 times 3 times 3 times 3 times 3.
times 3 times 3 times 3. And nobody would write out 5 3s. We would write out 3 to the 5th. We all remember that, yes? Excellent. Now, we are going to write over here on the side in this yucky blue that I don't really like. It's light blue. The rule here, or the law. X to the A times X to the B equals X to the A plus B. As long as they're the same base, we will add the exponents. Now, if something happens once in math, how often does it happen? Always. That's why math is the actually easiest subject to work with, because nothing ever changes. If it works once, it always works. That is not the case in very many other subjects. For example, in English, just for fun, how many different sounds do those letters make? O-U-G-H. I personally can think of 6. You know what sound they don't make? The sound they're supposed to make, which would be ugh. No word has ugh at the end of it, does it? But there's through, there's bow, there's enough, there's cough, there's hiccup, which is my personal favorite, when O-U-G-H makes the sound up. That's how you properly spell hiccup. Americans have spelled it H-I-C-C-U-P because, they also spell drive-through T-H-R-U. But that doesn't happen in math, because if something happens in math, it stays happening in math. That's why math should be your best friend, because it doesn't mess around. It doesn't wake up in the morning and decide it doesn't like you anymore. Okay? What if I'm dividing? In high school, do we ever write like that anymore? How do we show division in high school? Like a ratio or a fraction. 3 cubed over 3 squared. And again, what is the answer? Mantoge? Pardon me? That's what we do to get to the answer of 3 to the 1, right? We don't write the 1, but I'm writing it because I'm teaching it right now. Everybody's cool with that, right? Why does that work? Jordy.
Because we're saying when you write it in expanded form, 3 times 3 times 3 over 3 times 3, it's like you multiply them, but then you have to take them out again.
You got to cancel. Now, we all call it canceling. And when you guys cancel, you just cross them out and they disappear, don't they? Do they really disappear? What do they become? Pardon me? 1. 1. And I am left with 1 times 3, which is 3 to the 1. Everybody's cool? So how do I write that as my rule in light blue? X to the A over X to the B equals X to the A minus B. When is that true? Always, as long as the bases are the same. Is everybody good? Spectacular! Now let's go on to a third one. Raising an exponent to an exponent. 3 squared, which is an exponent, cubed, equals. What's the answer? Connor? 3 to the 6th. Why? That's what we do. Why does it work? RJ? Because I have 3 squared. Right. I have 3 squared 3 times. Which ends up being 3 times 3 times 3 times 3 times 3 times 3, which ends up being 3 to the 6th. What's the rule that we write in light blue? X to the A to the B is X to the A times B. Is everybody, all of you know this already, All of you have seen it before. All of you should be comfortable with it. Are you? Excellent. Now, do not write this down. Just think about it. Okay? The thing that messes kids up with exponents is you're all good at each rule until we pack 4, 5, 8 rules into one question. Then you start getting a little hinky, right? Let's start with an easy one. 3 squared. What's the answer? 9. Who said 6? Told you somebody would. Huh? Now all you laughers, that's pretty mean of them. I'm on your side though, Abby. Usually I keep tissue for just such an emergency. Okay, we're all cool, right? Okay. 3a squared. What's the answer? 3a squared. Why, Jordy?
Well, because a doesn't have a value.
A doesn't have a value, but why isn't this a 9?
Well, because like the exponent is attached to the a.
It's attached to the a.
3 times a squared.
Okay, so what is 3a squared? Mantosh? 9a squared. And that we're going to talk about that one a little later on. Good. All right. Again, you don't need to write this down. Just think. What is 9 over 3? Mantosh? 3. What is a squared? I lie. What is a to the 10th over a to the 8th? A squared. Okay. So what then, logically, is 9a to the 10th over 3a to the 8th? What? No. The a squared is right. Mantosh. 3a squared. Is everybody good? Those are the first 3 exponent laws, all wrapped together. Everybody should be like, yep, boom, no problem, got it, do it in my head, easy peasy, right? Okay. Now, we slide back over to here, and now we want to start writing again. A fraction base with an exponent. Okay? So that would be 3 over 2 squared. What is the answer? Mantosh. 3 squared over 2 squared, which is what? Because we would never leave it like this, would we? If I owed Caden $9, I wouldn't say, dude, you remember when you loaned me 3 squared dollars? Would I ever say that? No, I'd say 9. So what is the answer here? 27. 9 over 4. So we notice that the 2 went everywhere, right? Because this is really 3 over 2 times 3 over 2, right? Because that's the whole base. Can I forget about numbers 1, 2, and 3? I can't, can I? That's kind of like saying, I'm in grade 10, so I don't need to remember what I learned in grade 1 in math, do I? Or do you? Of course you do. So, knowing what you know, I got to remember numbers 1, 2, and 3. So what is a squared over b squared cubed? Knowing what you know, what would it be, Connor? 6th power. Yep. Now, is that 6 minus 6? Why not? Because the bases need to be the same. Excellently done. Now we get into the thing that all of you... Yes, Jordy?
Well, I mean, isn't there also a rule where it's like, can you do something like a minus b?
Okay. Now we're going to get to the next one. And all of you are going to know the first half of what I say, but you're going to have a little bit of trouble with the second half of what I'm going to say. I'll start with the first half, the part everybody knows. An exponent of 0. What is x to the 0? 1. Why do you know that? Because my grade 9 teacher said everything to the 0 power is 1. Right? Why is it, Vicky?
Because x to the power of 0 is just x by itself.
But then it would be x, not 1. Don't worry. I do this on purpose because nobody tells you guys why. Everybody says everything to the 0 is 1. And you're like, okay, so then what is this? What is that? 1. Because everything to the 0 power is 1. So what is this?
Do the negatives not matter?
We're getting to that. You don't give me away, Abby. What's this one?
What?
It's got to be 1 because everything to the 0 power is 1, right? But it's not. Because what's this one? Negative 1. Why? Jordy.
Well, let's say if you have like x squared, then you do x times x. If you have x to the power of 1, then you do just x. So if you go backwards, it's like you're kind of dividing x each time. So you actually have x to the power of 0. It's like x divided by x.
Absolutely correct. Did everybody follow what Jordy was saying? Some of you, yep, and some of you are like, nope. But don't worry, because I'm about to put what Jordy just said in very, very easy to follow form. RJ. The exponent tells you how much of the number you have, so I have 0. What?
If you have 0 the x, you won't have a 1. You have nothing. Yeah.
But if I have 0x, that means I have nothing, so why wouldn't the answer be 0? I understand. What I am hoping you are getting from what I am saying is that it's great if you know a fact, but if you don't know why it works, you're going to be in trouble further on. So let's talk about why this works. And we're going to talk about what Jordy said. What is 3 squared really? 3 times 3. Agreed? Which gets me 9, correct? Okay. Logically, if we're working down to 0, what is the next logical exponent? 1, which is 3, 1, 3. Agreed? Which gets me 3. What math happened here? We divided by the base, which in this case was 3, yes? Because I'm reversing exponents, so it must be dividing, correct? So logically, what is the next exponent? 0. Now, can I write anything there? I can't write anything, can I? Because it's 0 3s, so I can't write anything there. But if it happens once in math, how often does it happen? Always. So obviously I have to divide by the base again, which is what? 3. What is 3 divided by 3? 1. If it happens once in math, how often does it happen? Always. Here's the other reason it works. 3 squared over 3 squared. According to law number 2, what should I do with those exponents? I should subtract 3 to the 2 minus 2 is 3 to the 0, yes? What is 3 squared really? 3 times 3, which is really 9 over, what's 9 divided by 9? 1. So if that equals that and it equals 1, and that equals that and it equals that, then what do I know about 3 to the 0 and 1? That they are also equal. Everybody cool? That's why it works. And it's very important for when we get to number 7 on the next page. Everybody gets this? Everybody can tell me why? And then everybody understands this side of things when it's 1 and when it's negative 1? Okay. Whoa! Oh, okay. Ladies and gentlemen, that is the number one word you are going to hear from me. Why? I know how smart you are. I know you have good memories. I know I could tell you a bazillion facts and they would stick in your head. But what happens when you're in a situation that doesn't apply to those facts? Then you're screwed. That's why I spend so much time with why things work. Because then if something looks a little hinky, you can apply what you know for why things work and work it out. Everybody good? All right. I'm sliding on. Cool? Number 6 is an easy one. Number 6 should have been up beside number 5. I don't know why I moved it down here. You already know this because you already know that 3 over 2 to the 2 gets me 3 squared over 2 squared. So knowing what you already know, what would this be? X, y to the 2. What would it be? X squared, y squared. Easy peasy lemon squeezy, right? No problemo. Everybody can rock it. So how do I write that out as my light blue rule? Xy to the a equals x to the a, y to the a. Can I forget about number 1, 2, 3, 4, 5? No. I have to remember them too. So when you're done writing this down, I'm going to slide over to a blank page. I'm going to ask you to think again. We'll start with a nice easy one. 3x squared y squared squared. Connor.
3x to the 4th power. No, 3 to the 2nd, x to the 4th, and y to the 4th.
Is he right? Did he follow all the laws? That's law 3. Bringing the exponent into everywhere. Right? So he did well. Would he leave that? Caden, lend me $3 squared. What would I say? 9. So we would finish this off to 9 x to the 4th, y to the 4th. Everyone agree? Easy peasy. All right. What would happen if I added this to the equation? Again, I just want you thinking. Mantosh. Pardon me? That you say you want to bring that exponent down here? Is he right? Why not? Because normally the 2 should apply to everything, yes? What is keeping it from doing so? Riley May. There's no bracket. So what's the only base here? The 3x squared y squared, because the 2 isn't part of that. So we already know what the top is. 9x to the 4th, y to the 4th. What's the bottom? X, xy. Am I done? Why not? Now go. I'll let you redeem yourself.
Because it's the one remaining rule, law, which is the second law. So when you divide exponents, if there is no exponent to the immediate right, you just write a 1 there.
Mm-hmm.
So x to the power 4 and y to the power 4 minus x to the power 1 and y to the power 1 is x cubed and y cubed.
Everybody cool? Okay. Again, don't write, just think. Go ahead, Mandosh.
So now you put the 2 to the whole equation.
So what's the top?
It'd be 9x squared, x to the power 4 and y to the power 4. And the bottom would be x to the power 2, x squared and y squared. And finish off, you would divide the exponents, which would be 9x squared and y squared.
Everybody still cool? All right. Now, oh, Mr. Myers, you're so mean. You had a chance. You got to fix yourself even. Who wants to take over now? Okay, Hayden, hit me.
So the top would be the same. It would be 9x to the power of 4, and then y to the power of 4. And then the bottom would be, that would be 2 squared, so 4, 2, and then x to the power of 4, and y to the power of 5. It starts at 3. Oh yeah, sorry, 6.
Are we done?
No,
What now?
that would be, so you get rid of the, you cross out the x to the 4.
Why?
That would be a negative exponent.
It would be the same thing, right? 1 over 1. So that's cool.
Yes.
Then what's this?
That would be y to the power of negative 2.
And what would you do with 9 and 4?
You divide.
Can't do anything because 9 and 4 doesn't simplify, right? Now, what there bothers you? Jordy?
Well, I mean, because now you're making,
Mantos, what bothers you? That. What does that mean? Don't tell me what to do with it. What does it mean? Can it exist? Yeah, it can't exist, can it? Y squared exists. Y times y. Right? Y to the negative 2. How would I write that out? Can I? How would I write this out as repeated multiplication? But I can't write it this way, can I? I've got to change it around because this makes no sense at all. Right? Slide back over and notice what our last one was. Negative exponents. Now, have any of you not talked about negative exponents before? There's always a few, even in pre-dip classes. All of you have talked about negative exponents? Spectacular. So, you all already know that x to the negative y is 1 over x to the positive y, right? Because positive exponents make sense, negative exponents don't, right? And of course, you already could explain why because we did the zeros, right? 3 squared equaled 9, 3 to the 1 equaled 3, 3 to the 0 equaled 1. So logically, what's the next exponent? Negative 1. So I would divide this by the base, which is 3. So it would be 1 over 3. Logically, 3 to the negative 2, take that and divide it by 3. So that divided by 3 is the same as times 1/3, which is 1 over 3 squared, which is 1/9. Everybody is good there, yes? Now the shortcut that your teachers gave you is usually you bring the whole thing down here and you make it positive, right? Okay, then what is this? Mantosh. Okay, so what would it become? Mantosh. It would become 3 squared over 1, which would be 9 over 1, which would be 9. Everybody cool? Okay. So then, if everybody understands that, we're going to slide across a page, and I'm going to ask you a few questions. What is 1 over 4? Sorry, I'm an idiot. What is 4 to the negative 2? Mantosh. Which is 1 over 16, and we're done. Everybody cool? Okay. What is 1 over 3 to the negative 3? Mantaj.
3 cubed over 1.
Which is
27 over 1.
27 over 1, which is 27. Yeah? Okay. So what then is 4 to the negative 2 over 3 to the negative 3? Okay.
I'm not certain, but
That's okay.
I'm flipping the question. Like, so we bring 4 to the power of 2
Yep.
Which is equal to positive.
Yep.
Okay. Then 3 cubed is 27 and 4 squared is 16.
And then I'm done. Negative exponents reciprocate. Reciprocate is the $5 word for flip the fraction. Okay? I use real words every chance I get. Because when you go off to university, if your math teachers have been telling you stories about breaking princesses out of castles, and you go to your university professor and say, "Sir, how do I break the princess out of this castle?" He will laugh at you. Or she will laugh at you. And you don't want that. So I use the real words when I write it down. I'll say stuff, flip the fraction. But what we write down are the real words. Everybody cool? All right. So, can I forget about all my other rules? No. So remember right up here, we ended up with 9y to the negative 2 over 4. What is that really? Because what's not allowed there? The negative 2. So what has to happen? It reciprocates. Does the 9 reciprocate? No. Why not? Vicky? Because the negative 2 is only attached to the y. So this is 9 over 4y squared. Is everyone good? Okay. Prove it. Again, don't write it down. Think. Negative 2 x to the 3 y squared all squared over 6 x to the negative 3 y to the negative 4. Why does this become difficult? Because now, how many laws are in play here? All of them. Which means, is there any right spot to start? No. Could I teach you the right spot to start? I could teach you a right spot to start. Is it the right spot to start? No. So, you got to know all 7 and you got to apply them how you see fit. Now, without writing it down, because you don't need to, because we're only going to go step by step, is there anybody that would like to suggest a first step here? Just one step. Harry, you would deal with this. Okay, what would you do with that? It would apply to everything inside. So what would you get there? 4. What would you get there? X to the 6th. And what would you get here? Y to the 4th. Have you done anything to the bottom? So it stays 6x negative 3, y to the negative 4. Now, you are on Harry's math relay team. He did the first step. You're stuck with his work. Even if you wouldn't have done that, you're stuck here. What do you do next? Who would like to volunteer? Mantaj, go ahead. You're going to reciprocate. So you would do 4x to the 6th, then what? Well, you're not going to reciprocate a positive. Tag someone in. You got to work with Mantaj's choice. He wants to reciprocate, so what has to move? And y to the... Okay, so now that part of the relay is done. Now who's taken over? Mantaj. Or I'm doing it backwards. You're the O, he's the A. You collect your like terms to get 4... Yep. Everybody cool?
Don't forget the 6.
What haven't we talked about? We haven't talked about our friend 6. Now you're tagged in to finish the question. What do you do? This is the grade 3 part of the question that you already know. Abby. Jordy. Yep. 2x to the 9th, y to the 8th over 3. Everybody cool? Now, could you have done this a different way? You could have. Why did I make you work with the guy before you or the lady before you? Because you're going to approach every question with your toolbox of laws, not with a plan to attack it. Does everybody understand? Every question is slightly different. Sometimes you're going to go with this law, sometimes you're going to go with that law. That's why I like doing that relay thing. Everybody cool? All right, what if I gave you this one? It's almost the same, but I'm going to make this cruel, cruel, cruel. It's okay, Samuel, you can do it. Who wants to do the first step? Connor, what are you going to do first?
Put the negative 2 exponent that's on the outside into the equation.
You're going to bring the negative 2 everywhere inside.
Yes.
Okay, so you're going to have negative 2 to the negative 2. X to the what?
X to the negative 6.
Y to the what?
Negative 4. Or negative 8.
Over.
Yep.
What's going to be on the bottom?
6 to the negative 2. X to the negative 6.
Negative 6.
Positive 6. And same thing with y to the positive 8.
I'm telling you right now, that is not what I would have done first. But, because he knows his laws, we can still finish this. Some of you might disagree with Connor's first step, but you don't have a choice. You're stuck with it because he's the first guy in the relay. Who's going next? Caden, what would you do next?
I would reciprocate.
What?
So the negative exponents on the top would go to the bottom, and then the 6 to the negative 2 would go to the top.
And what would you do with this guy?
Those would go to the bottom.
So we already have x to the 6th on the bottom. We'd bring down an x to the 6th. And we already have a y to the 8 on the bottom, so
You have
another y to the 8 on the bottom. Then what? Tag, who's next? Vicky, yeah! Collect like terms. So 6 squared over negative 2 squared. X to the 12, y to the 16. Excellent. And tag, who's finishing? Come on, all the work's been done. Jordy, step in to finish.
Just put the brackets in for the negative 2.
Yeah, because that negative has always been part of it, hasn't it?
Yeah.
So what is this up top?
So that's 36 up there. And then that's the 4. And then x to the power 12. Y to the power 16.
And one last step, the easy one. Montage.
Divide 36 by 4.
Which is 9. Now it gets tricky. How do I write it? Connor. Full circle. Bring it home, Connor.
9 over x to the 12.
More steps than I would have done, but we got the right answer. Is everyone cool? You first.
Well, can I see how you would have done it?
Yes, I was hoping somebody would ask that. Okay, so how I would have done it would have been this. Let's choose a new color. Exact same question. This is what I would have done. As soon as I see a negative exponent, isn't this all a base? What do negative exponents do to bases? Flip them. So I would have gone right away to here. And then I would have squared it. Because it's flipped, that's now positive. And then I would have looked at inside here first because I don't want to distribute that 2 1,000 times. So I would have gone, okay, well, 6 divided by -2 is -3. 3 minus 3 is -6, right? X to the -6. -4 minus 4 is y to the -8. Then all that squared. Then -3 squared is 9. X to the -12, y to the -16. And then I move. Did I get the same spot? Would you all have gotten to the same spot? Does order matter? No. That is where we stop. Your job for tonight, and I'm sorry it took long, page 14 and 15. Some of it's a little hard to read, so skip them if you can't read it. But they are all one-step questions, and there's only 30 of them. It should take you about 15 minutes, max.